Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is 4-methylacetanilide, petoluidine acetylated at nitrogen, which has a paramethyl group on the benzene ring and an NHAC group. Moving on to the next step. Br2 in CH2, carbon disulfide, is a classic electrophilic aromatic substitution EAS condition. CH2 is a nonpolar solvent that favors electrophilic aromatic substitution without promoting free radical side reactions. This rules out benzylic or side chain radical bromination, which would require HV or peroxide. Moving on to the next step. The NHAC, acetamido, group is a strong ortho-para director. The methyl group is also an ortho-para director. The dominant director is the NHAC group. The para position relative to NHAC is already occupied by the methyl group. Therefore, electrophilic bromination occurs at the ortho position relative to NHAC, which is also ortho to nothing, blocking it, specifically at the position ortho to NHAC and ortho to the methyl group would be position 2, between NHAC at C1 and Me at C4. The open ortho positions are C2 and C6. C2 is ortho to NHAC and also adjacent to the methyl-bearing carbon chain side. And for the final step, with NHAC at C1 and Me at C4, the ortho positions to NHAC are C2 and C6. The position C2 is also ortho to the methyl group indirectly, meta to methyl, while C6 is meta to methyl. Actually, C2 is meta to C4 methyl and C6 is also meta to C4 methyl. Both ortho positions to NHAC are equivalent by symmetry. No, the molecule is 1 NHAC, 4 Me. So C2 and C6 are not equivalent because C2 is between C1, NHAC, and C3 and C6 is between C1, NHAC, and C5. However, C2 is closer to C4, Me, by 1 carbon than C6. Actually, both are equidistant, meta, to C4. By convention, bromination of 4-methylacetanilide with Br2 gives predominantly the 2-bromo product, ortho to NHAC, which is also ortho to methyl group on the same side, i.e., bromine enters at C3 relative to methyl or C2 relative to NHAC. The product shown in option D shows Br ortho to NHAC with Me at para. This is 2-bromo 4-methylacetanilide. Option A shows dibromination or incorrect regiochemistry. Option B shows alpha-bromination of the carbonyl methyl, which does not occur under EAS conditions in CH2. Option C shows benzylic bromination of the ring methyl group, which requires radical conditions, light peroxide, not Br to CH2. Br to CH2 promotes electrophilic aromatic substitution, and the NH-acetyl group directs bromine to the ortho position, C2, giving 2-bromo 4-methylacetanilide, which corresponds to option D. Therefore, the correct answer is D. Therefore, the correct answer is option D.